Hello, welcome to our unique learning system math lesson. My name is Charlotte Lucas. I am an autism low incidence mentor teacher with Richmond Public Schools, and I am delighted to be able to work with you today. Our math lesson today is writing and solving algebraic equations. We will start by examining a graphic organizer for algebraic equations. Then we will discuss our vocabulary words. And finally, we will use word problems to solve algebraic equations. We have a lot to do. So let's get started. This is our graphic organizer for today. The graphic organizer is designed to keep us on track, to help us to remember what steps we're on and what steps we have to do. I love a graphic organizer. It always is a great way to start. So we'll be using graphic organizer and word problems. And this is algebra. So we're going to be using variables, which are we'll be using alphabets instead of numbers to represent the unknown. First, we'll use the variables to write the expression for the equation, and then we will replace the alphabets with numbers and solve for the equation. For the variable that is unknown. It sounds like a lot, but when we use the graphic organizer, it'll be shown to you and it'll be very easy. So we've done this before. I'll move a little bit faster, but we've done this before, so it'll be quite easy for us. All right, let's start with a definition because that is always helpful. In algebra, we're working with certain conditions, so we want to make sure that we understand exactly what we're talking about. We are working with an equation. An equation will always use an equivalent operator between two math expressions. An equation, and you know the word equation comes from equal. So an equation will always use an equivalent operator. And the equivalent operator is that's right, the equal sign between two math expressions. All right, so let's find out what that is. Two math expressions. This is an expression. Right here we have the expression, a number, your mode of operation, and another number. That is an expression. All right, that's one expression. So here we have another expression. A number, the operation, which in this case is division, and another number. We have two expressions, and in between it is your equivalent operator, which is your equal sign. And the thing about an equal sign is you must prove that what's on one side of the equal sign is the same as what's on the other side of the equal sign. So you would test this to see if this is the same as this. If this expression is the same as this expression, yes, let's use the calculator. If we check this expression, now I have my calculator out, but my calculator has a number on the screen. So I'm going to clear my calculator. I use both clear buttons. So I'm going to clear my calculator and let's put in the first expression. Okay, 25 plus 7. 25 plus 7. And what is the answer? We hit the equal button. We get 32. Does that expression equal 32 to this expression, 64 divided by 2? This expression equals 32. Does 64 divided by 2 also equal 32? Let's find out. We have to clear out our calculator. And 64 divided by, the operation is division, 2 equals 32. So these two expressions are the same. They equal. So this is a true equation. Let's try the next one. An equation is always an equivalent. Let's get rid of this calculator. An equation is always an equivalent operator. Will always use an equivalent operator between two math expressions. Let's find the two math expressions. This is a math expression, and this is a math expression. We have two math expressions, and what's in the middle? The equivalent operator is the equal sign. Equivalent operator is the equal sign. And remember, if you have an equal sign, what's on this side of the equal sign must equal to what's on that side of the equal sign for the equation to be true. So let's check it. Let's get our calculator out again, because 20 times 5, let's clear our calculator first. Type in, click on 20 multiplied by 5. We hit the equal button, we'll get the answer, which is 100. So on this side of the equation, the answer is 100. Let's see if on this side of the equation, the answer is 100. Then we will have a true equation. The equation will be true. Oh, we need to what? Clear it out. Let's clear it out. And 80. The operation is addition plus 20. To find the answer, we hit the equal sign, equals 100. So this expression on this side and this expression on this side are the same expression, have the same answer. So they are equal, and that equation is true. So we know what an equation is. We need two math expressions, one on this side and one on this side. And in between is your equivalent operator, which is the equal sign. And whatever's on the left side must equal to what's on the right side, and equal means the same. All right, that's a lot of math. We're going to be great mathematicians when this is all over. So now let's go back to our graphic organizer. And we're doing algebra, and we need to write an equation. In algebra, we will be using variables. Variables are going to be letters, because we're going to replace the letters, the alphabets, I'm sorry, with numbers to solve the equation. So for our A is Ryan catches 23 rubber ducks at the duck pond game. You know that game. I played it. I never win. So Ryan catches 23 rubber ducks at the duck pond game. That's A. What's B? B is, Randy catches 9 rubber ducks at the duck pond game. So we have Ryan and we have Randy. Ryan is A, Randy is B, and C, the equation is how many rubber ducks do they catch all together? So the expression that uses all together means that our operation will be what? What operation will we be using? Do you remember? All right, let's see if we get it. The operation will be addition, because we use the word all together. So the expression will be A plus B equals C. That's the expression that we're going to use. A number A, and if we add that number A to a number B, those two numbers will equal to a new number, C. A number plus another number will equal to a new number, which is C. And these two numbers will be different, because otherwise it would be A plus A, the two same numbers together. But no, two numbers together will equal to a new number, C. So what is the number A? A is 23. So let's key in 23. That's A. Plus, we bring down our operation. Very important. B. Randy catches 9 rubber ducks. So B is what? 9. Okay. C is how many rubber ducks do they catch all together? Well, we don't know what C is right now. That's the question. How many will they catch all together? A plus B equals C. we have written our equation out, but we haven't solved for C yet, okay? A plus B equals C. And we will be solving to find out what is C. Let's try another one. So we've written our expression. We have substituted the numbers. We know what we're looking for. We're looking for C. Let's try this one. Let's write another one. Writing them gets to be pretty easy, doesn't it? All right. Brent gives out 12 pool noodles to volunteers at midday field day. Danielle gives out 3 pool noodles to volunteers at midday field day. How many more noodles does Brent give out than Danielle? The language is a little bit different this time. It says, how many more pool noodles does Brent give out than Danielle? When you're using language like how many more than, then the operation will be, and you know this, it will be subtraction. That's correct. So we know that our operation is going to be fraction. We already know that. So what's A? A is Brent. And what is B? B is Danielle. We have our expression. A, and our operation now is going to be subtraction because of the language. How many more than? So we're using subtraction. A minus B will equal to C. That is our expression. Now let's start substituting the numbers. A is what? 12. Now this part of it, we just substitute. Well, we know what A is. What is B? B is 3. And our operation, of course, is subtraction. And we know that B is 3. And, excuse me, and we're trying to solve to find out what will that equal to. And the variable C is the unknown. We have written a math expression, an algebraic equation to solve for C in addition and in subtraction using a word problem. I'm very proud of us. That's a very, very great thing that we've done today. All right, let's see if we can start solving. And that's a little bit more complicated, but it's just, again, it's just substituting. And we're using a graphic organizer again. I love graphic organizers. All right. So we know that our expression should read A plus B equals C. So we know we have an A, we know we have a B, and we know we have a C. All right. What is A? Mary Beth inflates 8 balls to use during midday field day. Midway field day. Okay. Mary Beth inflates 8 balls to use during midway field day. Okay. B. Randy inflates B balls to use during midday field day. Ooh, there's no number there. That must be that's right. That's the unknown. That's the variable we don't know. All right. C. They inflate 35 balls altogether. How many balls does Randy inflate? Well, we do know that if the language says all together, we do know that we're going to be using what mode of operation? That's right, addition. So the equation will read A plus B will equal to what? C. Okay, now we start substituting to find out which variables do we know and what will we be solving for. So variable A is 8. We substitute A and we get 8. For A, it's 8, okay? We know our operation is going to be addition because we have the word all together. And we've already figured that out. So we're going to use, we just bring down the equation. What is B? For B, we don't know what B is. B is the unknown. So we're going to just put here B because we don't know what that is yet. And then we know that if we add those two numbers together, whatever B is, it will equal to how many? C, which is 35. We did our substitutions. Excellent. that is our equation. Now we have to start solving. We have to solve. And what are we solving for? We're solving for B. We don't know what is B. We don't know what is B. Okay? We know that C is 35. We know that A is 8. So let's write our equation. Of course, if we want to solve, this is the rule. If we want to solve for B, we have to isolate, that means separate B, so that on this side of the equal sign, all we have is B. So what does that mean? That means we have to get rid of 8. We have to get rid of the number 8. And if we get rid of the number 8 on this side, then we will just have B, and that's what we're solving for. That's the plan. So in order to get rid of the number 8, what do we need to do? It's a positive number. So to get rid of it, we need to what? Subtract it. If you have 8 and you subtract 8, you're going to get a 0, which is you've gotten rid of the number 8. So on this side of the equation, we're going to get rid of the 8. So all that we have is B. All right, so that would be A. 8 is A. A minus A will equal to, oh, we got to put plus there. See, that's why the graphic organizer is so great. It keeps us in control, in order. Plus the B will equal to, now this is the trick. This is the trick. We're going to use C, but if we subtract something on this side of the equation, we have to subtract something on that side of the equation. Whatever you do to one side in order to isolate your variable, you must do it to the other side. So if I subtracted A on this side, I have to subtract A on the other side. Yeah, that's what I have to do. So subtract, and what are we subtracting? A. To solve the equation, we're using addition. To solve the equation, we have to use subtraction. So on this side of the equation, we needed to isolate and just have B. To do that, we had to get rid of the 8, which meant that we would subtract it. That would be 0. Then on this side, if we subtract something on this side, we must subtract it on that side. That's the rule. And that will solve the problem. So let's now substitute the numbers that we know. A is what? 8. 8, our operation remains the same. We've already figured that out. Minus 8. A, of course, which is 8. Okay, and then we add the B plus B. We bring all of this information over. It will equal to C, which is 35. And of course, if we subtracted 8 on one side, we must subtract 8 on the other side. So we're also going to subtract 8 from this side, which is the A. That's the way the equation will look now. We're trying to isolate that B. We want to get B on one side of the equation so that we can have the answer on the other side of the equation. Okay, so let's find out what is B. We're trying to figure out what is B. So if we have 8, take away 8, well, you know that's going to be 0. I don't think we need the calculator for that, but let's just put it up there because we have it. 8 subtract 8 will equal 0. So we know this, if we solve this side, if we solve this part of the equation, it's going to equal 0. plus B all right, we don't know what B is yet, so keep that in, and it will equal to whatever's on this side. And now let's solve this side, 35 minus 8. Yes, let's use the calculator just because we're in a hurry. So it's 35 minus 8. 35 take away 8 equals 27. So let's put that answer in. All right, to solve this, to find out what was B, we had to isolate it. So we subtracted A, which was 8, from itself, and that left us with B. And then if we subtracted on one side, we must subtract on the other side the same number. And we also subtracted 8 from this side. So this is 0 plus B equals 27. Now, when we bring that down, when we simplify it even further, we don't need the 0 plus anymore because that is not relevant to anything. It's 0. So we don't need it. So all we have left on this side is B. Isn't that what we were trying to do? We were trying to find out what is B. Now we know that B equals what? 27. B equals 27. After we have solved and used our rules to solve the problem, we find that we're saying that B will equal 27. Do you believe it? Well, don't just believe it, test it. Always check your answers, always. That way, you will always make sure that you have it correct. Checking your answer is just as important as solving the problem. Checking is just as important. So let's go back to our original equation, our original expression. It would be A, and we're using addition for this operation, plus B will equal, whoop, wrong thing, C. That is the expression. That is what we're trying to solve. At first, we didn't know what was B. We knew that A was 8, right? We solved the problem by isolating B and subtracting from both sides, and we found that B, we're saying that B will equal 27. So if we take the A plus the B, which we just found out, oh, that needs to be a plus sign. B, which is what? 27. Very good. We know that that should equal to what our original number is, which is what? 35. Very good. Got it. You've got it. So let's see if our equation, if the solution on this side is the same as the solution on this side. Once we've done our substitutions, now we add 8 plus 27. Use our calculator, may as well, we have access to it. Let's clear it out, and we 8 plus 27, what will it equal? Ta-da, it equals 35. So on this side of the equation, we now have what? 35. We use our equal sign because that is the way the equation equals 35. So now on this side of the equation, we have 35, and on this side of the equation, we have 35. They're the same. The equation is now true. So is the equation true? Yes. The equation is true. So since B will equal to 27, Randy inflates 27 balls to use at midway fill. Since B is 27, Randy inflates 27 balls to use at midway field day. We solved the problem. What did we do? We substituted. First, we created our equation using the variables A, B, and C. Then we wrote out our equation, A plus B equals C. We knew that we substituted the numbers for the variables. We knew that A was 8. We didn't know what B was, but we knew that C was 35. So we knew we were solving for B. We rewrite our equation so that we can isolate B. And the way that we do that was, since we were using addition, we used subtraction to solve. And we subtracted A from A to get 0 so that we could isolate B on this side of the equation, which we did. And then if we subtracted that number 8 from this side of the equation, we must also subtract it from this side of the equation, the equal. On one side of the equal sign to the other side of the equal sign. We subtracted. And when we did that, we found that B would equal 27 because we no longer needed this part. We got rid of it. And what we were left with is B. So we isolated B to equal 27. So we surmised that we decided we were able to find that B would equal 27. Well, it wasn't enough that we solved the problem. We have to check our work. It's always a good idea to check your work. And we are using a calculator because we're not trying to check to see if you know how to add. What we're trying to find out is, can you substitute and create your algebraic equations, which because of that, we're able to use our calculator, because if we were learning to add, we couldn't use a calculator. So tell your parents we use a calculator because we're learning algebra, not how to add. So we were able to isolate B. We found that B would equal 27. Now we're checking our work with the original expression, A plus B equals C. So if 8 plus 27 should equal 35. We solved this part of the equation because there was an operation there. 8 plus 27, we found that it was 35 on that side, which equals to 35 on this side. That means the equation is true. And then we're able to say that since B is 27, the answer to the question, the question was, they inflate 35 balls altogether. How many balls does Randy inflate? All right, so since we were able to solve for B, we're able to say that since B is 27, Randy inflates 27 balls to use at midday field day. Woo! That was a lot of work. It was a lot of work, but you did a great job. You worked all the way through. You were very patient. This is a lot of changing and substituting, but if you take the time to go through each step, one step at a time, solving each step as you go along, you will always get the right answer. So let's review our vocabulary, because that was very important for us today. We were using an equation, and an equation will always use an equivalent operator, the equal sign, between two math expressions. So the math expression is a number, an expression is a number with a mode of operation between another number. This number added to this number, okay? So that's an expression, but an equation will use two expressions with an equivalent operator between the two. That was very important for us to understand before we got started. So we're able to see, and the other part about this equivalent operator is that whatever the answer is on this side, it has to be the same as whatever the answer is on that side of the equation. That's what equal means. It means the same. Well, guys and girls, you have done a great job, and I'm very proud. We will get an opportunity to do some more algebra next week. I look forward to seeing you at that time. Be good. Bye-bye now.